last section of chapter 12. This is it. We are doing a really short unit on limits. We are going to finish this section today, and then when we meet next for class, after this specific section today, you're going to have one Delta Math review assignment, and then next week we're going to have some more review, and then we're going to have a short assessment to cover limits and to see what you know. So let's get into this last section here. We're first going to review some limits just because review is always helpful. And then we're going to look at one last technique when we find the indeterminate form. So number one here, big thing to remember, as we shift back and forth between evaluating a limit at a number and evaluating at infinity, is that when we are evaluating a limit at a number, we always want to start with direct substitution. So direct substitution gives us the square root of, we're evaluating this at 81, so this is the square root of 81 minus 3. Square root of 81 is 9, and so that's 9 minus 3, or a value of 6. So that means the limit as x goes to 81 of x, square root of x minus 3 is 6. Next up, let's do number 2. That gives us the square root of 1 minus 3 over 1 minus 9. That gives us 1 minus 3, which is negative 2 over negative 8. That comes out to positive 4. So it looks like we get a value of positive 4 as x goes to 1 for our limit. So then let's go to number 3. The question is, can we evaluate the limit as x goes to 9 of the same function we worked with, the square root of x minus 3 over x minus 9, using direct substitution? Well, let's try it. This becomes the square root of 9 minus 3 over 9 minus 9. Well, that's 3 minus 3 over 9 minus 9, which is our indeterminate form of 0 over 0. This means not necessarily that the limit doesn't exist, but this means that the direct substitution doesn't work, so we have to do something else. So generally with this function, the next method, so we do, our order is direct substitution first, and then next up was factoring. Well, here's the thing. I can just tell you this upright. When something has a square root, with the methods that you know, factoring is near impossible. It's going to be very difficult to do, and I'm not going to expect you to solve this by factoring, but we have another technique. So we've got our indeterminate form. This describes what we remember about the indeterminate form. When direct substitution is not possible, there's no factorable expressions, we don't have anything that's squared, another technique to try is rationalizing, which I'm going to talk about what that means. So rationalizing our function. Rationalizing is a fancy way of saying get rid of the square root. And in order to get rid of the square root, we are going to use something called the conjugate. So I will refresh your memory if you're like, but still I have no clue what the conjugate is. If I have something like the square root of x plus a, its conjugate is the square root of x minus a. We keep the values the same and we switch out the signs. And then it looks like this has frozen real quick, so let me just restart this. Thank you for your patience. This has been happening a lot more recently, which is great. All right, so then that's the conjugate. So what happens is when you multiply these together, when you take two conjugates, so the same numbers, we just switch it from a plus to a minus or from a minus to a plus, what happens is this is a difference of two squares, and if we were to factor this all the way out, and you could do this work on your own if you don't believe me, we are going to end up the square root of x times the square root of x just becomes x. This is going to become x minus a squared. So what we can see here is that it gets rid of the square root, because when we do those middle terms, we have positive ax, we have negative ax, those will cancel out. So we're going to use the conjugate here. So now what we're going to do is we're going to find the term that has a square root, that's the square root of x minus 3, and we are going to multiply the top and the bottom by its conjugate. So I'm going to put a multiply. I'm going to put my fraction. Now you might think, hey, Miss Silly, I can get rid of a square root by squaring it. When it comes to fractions, the only method that keeps the fraction balanced, that doesn't change its overall numerical value, is multiplying by our special one, multiplying by the same quantity over it. Squaring does not keep it the same, so we can't do that. That's why we do this. So the square root of x minus 3, its conjugate is the square root of x plus 3. And then we have to do the same on the bottom. All right, so we multiply this. So as we do this, we're going to keep simplifying. We're going to carry down our limit notation, limit as x goes to 9. So now this becomes, which I'm going to write it out for this step, this becomes the square root of x minus 3 times the square root of x plus 3, and then x minus 9 times the square root of x plus 3. For the sake of this problem, I would encourage you to leave that denominator, or leave whenever we have the term multiplied with square roots, don't distribute it out. Leave it like this. So let's keep going. Limit as x goes to 9. This is the difference of two squares, and so this becomes x. When we do the square root of x times the square root of x, this becomes x minus, and then 3 times 3 is 9. So this becomes x minus 9 in the top. Again, if you don't believe me, let's multiply this out. First term, we get a square root of x squared. Let's distribute it again. Plus 3 root x, distribute over here, minus 3 root x, then one more time, minus 9. Each and every time when you do it, the middle terms cancel. That's why we like it. That's why we do it. And that's why we get x minus 9. And we'll see here, conveniently, I see something nice happening. On the bottom, I still have x minus 9 times the square root of x plus 3. And this is awesome because it didn't look like anything was going to cancel out any common factors, but now I have a factor of x minus 9 at the top and bottom, that factor, and they are gone. So that means this becomes the limit as x goes to 9 in simplified form of 1 over the square root of x plus 3. Now, we rationalized it whenever you, so here's kind of, it's the direct substitution sandwich. We start with direct substitution. It doesn't work. We try something else. You always end back up with direct substitution again. So we plug it in. This becomes 1 over the square root of 9 plus 3. Square root of 9 is 3, so that's 1 plus 3 plus 3, or 1 over 3 plus 3, and that is 1/6. So this limit, it started out giving us the indeterminate form. It ended up having a numerical answer of 1/6. And that would again indicate that there's a hole in the graph at x equals 9. Let's look at a couple more examples. For this next one, we have the limit as x goes to 1, the limit as x goes to 1 of 1 minus square root of x over x minus 1. Where do we start? Direct substitution sandwich. We always start with direct substitution. So this is 1 minus square root of 1 over 1 minus 1. That does give us our indeterminate form of 0 over 0. So we have to try something else. So this is a point where you look at it, you remember, hey, Miss Tilly told me in that screencast that I can't really factor a square root easily. So instead, we have to use rationalizing. So we're going to take the term, and this time they are switched in order, but that's okay. Its conjugate would be 1 plus square root x. We multiply by that. This becomes the limit as x goes to 1 of 1 minus square root x times 1 plus square root x over x minus 1 times 1 plus square root x. Continuing, this becomes the limit as x goes to 1. And then that top term, we square, essentially you square the outside number. So it's 1 squared, which is 1. Put a minus in the middle. And the square root of x times the square root of x just becomes x. So it becomes 1 minus x over x minus 1, 1 plus square root x. And we don't want to get too excited about canceling because the order, this looks like x minus 1, except it's 1 minus x. The order is flipped. So here's an important algebra thing that we can do. I can make the numerator look like the same order, x minus 1, if I factor out a negative. So this is the same as negative x minus 1, factor out the 1, over x minus 1, 1 plus square root x. So now I can cancel out the factor, and this becomes the limit as x goes to 1 of -1 over 1 plus the square root of x. So we've simplified. So all the middle steps was all the steps in orange is just the purple step was doing the rationalizing. The orange steps were all the math to clean it up. Now that we've cleaned it up, we've rationalized, and we've gotten rid of that 1 square root. Now we are going to substitute. We're going to do direct substitution. Sorry, I lost my train of thought there. Okay. I can't switch colors. Well, let me just start this real quick. Thank you for your patience. Okay. Last but not least, here we go. So we have direct substitution. And so then now this gives us -1 over 1 plus the square root of 1, which is -1/2. So this limit as x goes to 1 comes out to be -1/2. I realize it's a little late now. I forgot to say this at the beginning of the problem. This problem in black I just wrote in, so hopefully you caught on and added this into your notes. And then for this next one, the limit as x goes to 4 of x minus 4 over square root of x minus 2. What I'm going to do is I will work this through in the notes so you can follow all these steps through to look for another example. And then what we have up next is a assignment. Rather than having a practice set, we are going to do an assignment on Delta Math. So please look for that. That is going to be due the next time we meet. So if you're an odd period class, that will be due by Monday. If you're an even period class, that will be due by Tuesday. Have an awesome long weekend, and let me know if you have questions.